This is a JAMB chemistry question, and we are asked to find the mass of hydrogen gas that will be liberated when 6 grams of magnesium remain dissolved in 500 cm cube of 6 molar HCl. The first thing we need to do here is to write a balanced chemical equation, because this is purely a stoichiometry question. So we have Mg reacting with HCl, and this would give us MgCl2 plus hydrogen gas. Now, this equation is not balanced. Mg is balanced, but hydrogen and chlorine, we have 2 on this side and we have just 1 here. By putting 2 here, this equation will be balanced, and that implies that the mole ratio here, based on this balanced chemical equation, is 1:1:1. So 1:1:1. Now that is settled, I'm going to be dividing this into 2 sides. So let's one of these sides. So I'll be dealing with magnesium from this end, and I'll be dealing with HCl from this end. From this place, what we notice is that we were given 6 grams of magnesium. So we're given a certain mass of magnesium, which is 6 grams. And then we were also given that the molar mass of magnesium is 24. So molar mass of magnesium, let me call that mm, that is 24. If this is stoichiometry, in stoichiometry, we can only compare with number of moles and volume, especially if you are dealing with gases. That's for volume of gases. But now that we're dealing with these substances, we can only compare with number of moles. We can't compare with this mass that was given. Therefore, we need to find the number of moles of this, which is mass divided by molar mass. That implies that the number of moles of magnesium equals 6 divided by 24, and if you press that on your calculator, you have 0.25 mole. Now, before we proceed, we need to go and do for the number of moles of HCl as well. In this case, we were given the molarity and then we were given the volume. First, we need to convert the volume to dm cube, and to do that, 500 cm cube of HCl was given. We need to divide it by 1000. When we divide it by 1000, then we get 0.5 dm cube. Now, to get the number of moles now, that will be the molarity multiplied by the volume in dm cube. The molarity is 6, then the volume is 0.5 dm cube, and that implies that we have 3 mole here. Now, this is where the comparison now starts. Now that we have these 2 information now, based on the ratio, so coming to this side, the ratio of Mg to HCl is 1:2. And I'm going to be using that information. Now, Mg to Cl, that is 1:2. Let me extend this. I'm still partitioning them. Yeah. Now, the ratio of Mg to Cl is 1:2. Therefore, if we have 0.25 mole of magnesium, which is what we have here. Now, let's assume that we don't have any information about HCl. This is HCl rather. So let this be X. So if you solve for X in this place, that implies that the amount of HCl that you will need in terms of mole is 2 times 0.25, which is 0.5 mole. So that implies that you need this amount of HCl to react with what was given as far as magnesium is concerned. Let's go and do the same thing here. So we have that Mg ratio HCl is still 1:2. But what do we have here? We have information on HCl, which is 3 mole. So therefore, let X be here. If you solve this now, that implies that, let me make this Y so that we'll not be confused. Now, if you solve for Y here, this implies that 2y equals 3, and that implies that y equals 1.5 mole. That implies that for HCl that was given, we need 1.5 mole of magnesium. So magnesium needed. Now, this is where the comparison starts, because for this particular question, we can't just pick any of these magnesium or HCl to determine the mass of hydrogen gas, we have to know which one is the limiting reactant. So this is the first thing we do to determine the limiting reactant. To determine the limiting reactant here, we will compare what we have with what we needed. According to this, we need 0.5 mole of HCl. But what do we have? We have 3 mole of HCl. That implies that what we have for HCl, which is this 3 mole, this is what we have. And this is what we need. What we have is more than what we need. That implies that we have excess reactant. So HCl is in excess. If we go and compare this, what we need for magnesium is 1.5. This is what we need, 1.5 mole. But what do we have? We have 0.25. What we have for magnesium is lesser than what we need. That implies that this magnesium is the limiting reactant. So it's limiting reactant. Hence, this will be the one that will determine the extent of reaction, that is the magnesium. And then we already have the number of moles of magnesium. We just need to compare it. So this is 1:1. So the magnesium ratio hydrogen gas is 1:1. Therefore, if they are in the same ratio, and then the number of mole of this is 0.25, hence the number of moles of hydrogen gas will be X as well. Since they are the same, that implies that X is 0.25 mole. Now, the next thing we need to do is to find the mass of hydrogen gas as required. That's what the question asks us to find. And we can use the stoichiometric expression that says number of moles equals mass in gram over the molecular mass of hydrogen gas, which will be 2 times 1. And then that implies that mass equals number of moles of hydrogen gas times 2. Number of moles that we have gotten here is 0.25, then multiply by 2. If we do this now, this will be 0.5 gram. That implies that the mass of hydrogen gas liberated is 0.5 gram. Note, you always need to find your limiting reactant. You can't just pick any random one that was given and just use it to determine the extent of reaction. If you want to see more videos like this, subscribe, follow, like, comment, and share. I'll see you in the next one.